Hello everyone. In this video, we're going to be comparing two numbers, very large numbers. We have 5 to the 15th power and 3 to the 23rd power. We're going to try to find out which number is bigger, larger. And I'm going to give you the numerical values at the end so that you can kind of see how many times the other number or one number is bigger than the other one. So make a guess first. Do you think they're pretty close or they are far apart? Think about the ratio of the larger number to the smaller number, and then we'll check that at the end, okay? So notice that we have 5 and 3 at the base. So how do you compare different bases, right? If we had the powers of 5, of course, that would be too easy. Or if we had 5 and 25, or maybe even 125 and 25, both of them can be written as powers of 5, right? Then it would be fairly easy, but we're not talking about exercises here. These are problems, right? Hopefully you know that on my channel, I have problems, not exercises. You'll find a lot of exercises in textbooks, which is kind of boring because you keep doing the same thing over and over. Sometimes people call that drill and kill, right? Anyway, so let's go ahead and see how we can compare these two numbers without using a calculator. Of course, that is the trick, right? You don't want to use a calculator. That would be cheating. Or you can't use logs either because, again, that will be using a calculator. And what do I mean by logs is, let's say you take, like you log this number. This will be equal to 15 times log 5. You know that by properties of logarithms. So if you knew the log of 5, base 10, obviously, right? Then you could just multiply by 15 and that would give you a value. And of course, whichever number has a bigger log, that will be a bigger number because the log function is always increasing, right? Or always decreasing, of course, depends on the base. So that means there's going to be a unique solution. But we don't have that opportunity. So how do you solve? That's the trick. How do you solve without using a calculator, without using any lookup tables? All right, let's go ahead and see how we can do that. So in order to be able to compare 5 and 3, because they're both prime numbers, they don't have anything in common, what we're going to do is we're going to try to use powers that are closer, okay? What do I mean by that? Let's go ahead and make a list of powers of 5 and then powers of 3, and then I'll show you. And actually, that's the idea how this problem came about, because you'll know what I'm talking about in a little bit, okay? So, for example, start with 5, which is 5 to the first power. And then second power is going to be 25. And then you're going to have 125, 625, 3,125. Hopefully you know this. This is not too hard. Once you know that, you can keep doing this, right? Now, we don't need to go too large here, because if you think about powers of 3, they don't grow that fast, right? So 3, 9, and then 27, 81, 243, 729, I think 2187, so on and so forth. So notice that these numbers are kind of close. One of them is like 3,000, the other one is 2,000, but not ideal, right? They're not that close. We are looking for two numbers that are really, really close. Okay, and they can't be 5 and 3, of course. They are close, but it's not going to help us. We need bigger powers. So if you look at these two values, lists or table, whatever you want to call this, you can make a table, right? Then you're going to realize that, 25 and 27 seem to be pretty close, right? If you divide 27 by 25, you're going to understand what I'm talking about. Now, they're not just two apart, but the ratio is also very close to 1, don't you think? 1 point something. 1.1 is even going to give you a bigger answer, I think, because think about it. If you multiply 25 by 1.1, what do you get? 27.5, exactly. So 27 divided by 25 is close to 1.0 something. You see, they're pretty close. But what are we going to do with them, right? So we're going to start with the following. Everybody hopefully knows that, right? 27 is greater than 25. I'm just going to explain everything step by step so you can now apply to other problems. By the way, I made a bunch of videos on comparing numbers, most of the time using exponents, sometimes radicals, sometimes the binomial theorem, a bunch of different ideas. Go ahead and check them out, but make sure you understand the ideas here first. I also have another channel that focuses on complex numbers. It's called A plus BI. Hopefully you'll remember that, right? Because that's how you write a complex number. Of course, YouTube doesn't allow you to pick a handle that has a plus sign, unfortunately. Otherwise, I would grab it, right? Definitely. That would be really cool, but it doesn't allow you to do that. I tried it. Trust me, I could only get this one. Pretty close, isn't it? Now, 27 is greater than 25. Everybody agrees? Okay, shake your head, nod your head. Now, 27 is 3 to the third power, right? And 25 is 5 to the second power. This is a good thing about listing the powers because this way you do know which power is which. Of course, these are small numbers. You probably know, hopefully. Now, this means in terms of our exponentials, 3 to the third power is greater than 5 to the second power. Good. But how do we go from here to these? We have 3 to the 23rd versus 5 to the power 15. Okay. Now, if you think about it, there's a couple of things you can do. One, you can try to bring these closer together. Like, how can I get close to 23? Well, one way to do it is I can multiply by 8. In other words, I can take these, right, and raise them both to the power 8. And of course, the inequality will be maintained, right? If these numbers are arranged like that, of course, their 8th powers are going to be that way too because they're positive. Now, this gives you 3 to the power 24 is greater than 5 to the power 16. Wait a minute, this is problematic because they're bigger than our numbers. So you don't want to exceed them, right? You want to be smaller. And guess what? If you're close but smaller, then you can always adjust it by multiplying by something. That's what we're going to do. This is the critical part. So I really want you to understand it. 8 is too big. Use 7. At least give it a try, right? So let's go ahead and raise both sides to the 7th power. That's going to give us 3 to the power 21 is greater than 5 to the power 14. Notice that both the 21 and the 14 are less than 23 and 15. But that's okay. Like I said earlier, we are able to fix this with a quick mathemagic. Okay, ready for the hocus pocus? Okay, great. Now, since 3 to the power 21 is greater than 5 to the power 14, the left-hand side is bigger, right? Yep. So what I'm going to do is I'm going to multiply both sides by some numbers, but not the same number because here I'm going to multiply by a power of 5. Here I want to multiply by a power of 3. But guess what? If I multiply the left-hand side by a smaller number than I do on the right-hand side, then inequality may be broken. But if I multiply the left-hand side by a larger number than the right-hand side, then the greater number will even get greater, but it's still going to stay the same basically, right? Not in value, but it's still going to be bigger. So here's what we're going to do. We're going to multiply 3 to the power 21 by 3 to the second power, which is 9. And we're going to multiply 5 to the power 14 by just 5 to the first power. And that kind of makes sense. You know why? Because your goal is to get to this, right? 3 to the power 23. To get from 3 to the 21st to 23rd, you need the second power. Does that make sense? Now notice that I took a number that is larger than another number, and I multiply the larger number by 9. I multiply the smaller number by 5. What happens? We still have the same inequality. And guess what? This gives you the answer. Because if you simplify this and this, then you get 3 to the power 23 is greater than 5 to the power 15. And yes, 3 to the power 23, the one with the smaller base, wins. And a lot of times people are going to say, oh yeah, it's almost always the number with the smaller base, right? Because the base is important. Exponent is important, but the base is what you multiply every time, so that's going to multiply the number faster. Does that make sense? I hope it does. Let me go ahead and give you the values, then we can just go ahead and finish up here. Ready? So 3 to the power 23 is 94,143,178,827. I didn't calculate this by heart. I just used a calculator, or Desmos, right? Or Wolfram Alpha. What about 5 to the power 15th? You want to guess? It is 30,517,578,125. Of course, it ends in 5 because all powers of 5 end in 5. And notice that the number that is bigger is a little more than 3 times bigger. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out SyberMath, the Shorts channel, and aplusbi, and bye-bye.